right, we're back for the next episode of the All Things Facades podcast, and this one's going to be a deep dive on concrete and if it's a sustainable building material. So we're here with the concrete experts from Clark Pacific. We have Doug and Blake, and I haven't seen the two of you since we were checking out buildings in San Diego, so it's great to see both of you. But if you both want to give a quick intro, Doug, we could start with you on who you are and then a little bit about Clark Pacific's background.
Yeah, certainly. So my name's Bevier. I've been working with Clark Pacific for the last 14 years. I guess industry experience has been with Clark Pacific and with Precast. Started when I was young, worked on the line, worked in the field, and fell in love with Precast and went to school, came back as an engineer, and then have done different positions throughout my tenure. Started in project management engineering, was our facade product developer for a handful of years, and now run our sales department for facades, and we do both traditional precast, what I call thin shell, and GFRC. And then just a little bit about Clark Pacific. This is our 60th year, so we've been a family-owned business. My grandfather Jim Clark started the company, started as general manager at the company in 1966. His two sons, Bob and Don Clark, are both co-CEOs now, and there's a handful of us that we call a third generation here at Clark Pacific. We've been doing facades and prefabrication for those entire 60 years, and we do a ton of other products, including data centers, stadiums, structures, all throughout the West Coast. Blake, do you want to give a quick intro to you and some of your background?
Yeah, thanks. First, I just want to say, Adrian, what you've been able to do with this podcast and your online content on LinkedIn and everything is just remarkable. For building envelope systems, how you've been able to make that something that's exciting. Come on, we're talking about building skins. It's impressive, and just want to say thanks for allowing us to join you. I feel like I'm on a call with kind of a superstar.
So if people can't tell, Blake is the structural in the background.
And this is what I think is really interesting. I appreciate it, Blake, is that Blake has a really diverse set of knowledge and experience on the structural side, but really what Clark Pacific is able to do is integrate the facade into the structure. So don't let me take the mic away from you, Blake. Go ahead.
Yeah, so I'm a structural engineer. I've been with Clark Pacific for a little over 4 years. I spent a decade in the consulting industry, working as a kind of a traditional structural engineer, working with architects and general contractors on doing building design. I had an opportunity to come over to Clark Pacific to get involved in kind of the early business development, pre-construction, and product development side of things, and work on some really exciting big projects and have a pretty big role in impacting the direction of those. And so I took that opportunity, and it's been the greatest decision of my professional career, absolutely. And so here at Clark Pacific, I get involved early in projects to work with the designers and the owners to help them to make decisions that will be best for an efficient precast design. I don't get involved with the facades nearly as much as Doug does, so I'm mostly on the structure side, but I do have some knowledge to share about embodied carbon and sustainability of concrete, and hopefully dispel some misconceptions about what this building material is and what its sustainable possibilities are.
So before I put Blake on the spot, just for anybody that isn't familiar, Doug, could you just give a quick kind of elementary explanation what the difference is between precast concrete? I don't think people know what that term means, versus cast in place concrete.
Yeah, we can talk about some of the key differences. Cast in place and precast are going to have some similar alignment in our embodied carbon and sustainability approach, but really are talking about apples and oranges, right? So your cast in place is going to be just like it sounds, concrete that's cast in the field, and there's different means and methods of doing that. There's going to be different types of mix designs and things like that are going to be strictly CIP, right? When we talk about precast, it's pre-cast, right? So prefabricated, it's cast off-site at a manufacturing facility. Every precaster may have a different set of products that they're set up to do, or the infrastructure that they have to cast it. But because we have the unique abilities to kind of have perfect working conditions, some of our strategies are going to be different than CIP, and I think we have a lot more opportunity in the precast realm when talking specifically about embodied carbon.
Okay, so before we get really into the nitty-gritty of it, Blake, because Doug might be a little bit biased because he was born into this industry, but because you have so much experience outside, especially working as a consultant for many years, why do you think there's a negative stigma overall when it comes to concrete and overall carbon or global emissions?
Well, I think it starts with a misconception about concrete is versus cement. A concrete layperson outside of the construction industry thinks those are synonyms, right? Oh, cement building. Look at that cement building. Well, that building is not made of cement. You know, there's concrete structural components that go into the construction of that building. What's the difference between concrete and cement? Well, cement is one of the ingredients that goes into a concrete mixture. It would be analogous to, say, a cake, call it a birthday cake, where the flour is the cement, but there's other materials and ingredients to go into the baking of that cake, right? And so that's a big misunderstanding. And you talk to anybody that's not an engineer, and even people inside the construction industry that don't understand the differentiation between those two products and materials. So I think that's probably the biggest problem.
So if you look at that pie of what comprises or makes up concrete as a whole, other than cement, what are the other big ingredients?
So concrete consists of water, fine aggregates, so like sands, and then a coarse aggregate, which is kind of like gravel, right, 3/8 inch to 1 inch in size. And then you have your cementitious material, which most commonly is Portland cement. And then you have other admixtures that go into it. But those are your main ingredients that go into your concrete mixture. And by far the most influential ingredient to the global warming potential or the embodied carbon of the concrete is the Portland cement. In fact, it's upwards of 90%, depending on the compressive strength of the concrete that you're trying to get. Which now you start looking at concrete versus cement, we're telling a completely different story now. If you're saying that, oh, concrete's not sustainable, well, no, it's 90% cement. So really what we need to do is tackle the problem of Portland cement.
Okay, so the answer necessarily isn't less concrete volume shrinking the structure or lowering the overall density, but finding a way to reduce the global warming impact of the, what would it be? And I'm trying to find a way to properly articulate it. Lowering the Portland cement content?
Yeah, it's both. Absolutely, it's both. So there's a lot that goes into both sides of the equation. Now, it's not just reducing the overall global warming potential of the material, but we also put a lot of effort and a lot of study into reducing the amount of material that we use, right? So it's two approaches to solving this problem. And with precast concrete, what we're able to do that's an advantage over cast in place concrete is we're able to design products and shapes and forms that are very efficient use of material. So we're reducing the amount of concrete in a structure compared to cast in place by about 30%.
And why don't Blake just add a question in here? Why don't they do that in CAP, or why is that not a strategy incorporated in that industry versus precast?
Yeah, it's not economically feasible. The reason that cast in place concrete structures are built the way that they are is to reduce labor cost. And it's very cheap to place a flat deck and do a flat slab where you've got a crew of workers shaking out rebar and pouring concrete on a flat deck. You used to see waffle slabs more commonly in construction in the US, and maybe in other parts of the United States, they still do it. We don't see it here on the West Coast anymore, but that would be more efficient. A flat slab it uses a lot more concrete to achieve the stiffness and the strength necessary to achieve the long spans that you need in a building.
And so then you can also think of it, right? So in the cement, which we're seeing is upwards of 90% of the embodied carbon, right? Why do we need it, right? It's your glue, right? It's the clinker that takes a lot of energy to produce, right? You're heating this material up, it has a byproduct of CO2, and it's just a high intensive energy activity, right? And so part of it is going to be, how can you get more effective concrete mixes, meaning how can you get stronger? How can you span longer? How can you use less of it, right? Which precast does a great job of of being able to utilize, different types of formwork and pre-stress and different strategies to do that. But it's also going to be, if we are trying to reduce or substitute that cement, we have other advantages to introduce energy here at the facility that you might not have at, out at the job site. And so, it's going to be balancing two sides of the sword.
How do you find that balance in terms of if a designer or architect or somebody is trying to weigh the carbon impact of utilizing precast concrete or cast in place concrete, how much of it is actually contributed from the material itself versus how the material is sourced or produced?
If I can kind of set the stage a little bit to provide some kind of technical information about how concrete cures, right? Because I think that's important to understand. So the concrete curing process it's a chemical reaction that occurs between the water and the cementitious material. And like I mentioned earlier, in most cases, is Portland cement, and we call that it's hydration, right? It's a chemical reaction. It's just not as exciting as the chemical reactions that you might remember from your chemistry class, where something explodes or overflows the beaker within seconds, right? The hydration process takes time, and it's an exothermic reaction, which means it gives off heat, and that heat helps cure and harden the concrete. And the Portland cement, as mentioned by Doug, the production process for Portland cement requires intense amounts of energy in order to turn that material into a reactive substance that has the properties necessary to create that chemical reaction, right? And so that's why that Portland cement has such a high carbon footprint, because of the carbon emitted in its manufacturing process. So if we want to, say, reduce the amount of Portland cement in the concrete mix, that is going to reduce the amount of reactive material in the concrete, right? That creates the hydration the hydration process. So it will prolong the curing of the concrete, which is bad for business, right? It's bad for business because in precast concrete, and we can talk about both precast and cast in place, but in precast concrete, we've got formwork, we've got beds that we need to turn every day, right? In order to be profitable, we need to reuse that form every day so that we can produce enough product to meet the schedule. Now, it's a problem in cast in place concrete because of a similar concrete that takes too long to cure, and you've got to wait till you can, strip the forms and jump to the next level. And so you have to come up with a way to reduce the cure time so that you can be profitable and hit schedule. And so being in a controlled manufacturing environment like you are with precast, we have the ability to put in external energy into the concrete or heat in order to accelerate the hydration process. And we can replace Portland cement with what we call supplemental cementitious materials, SCMs. And there's a number of SCMs that are available, and depending on where you're located in the U.S. or if there's people outside the U.S. around the world that are listening, it's going to vary, right? Here on the West Coast, we use a blast furnace slag, which is a byproduct of iron and steel production, and it's a very reactive substance compared to other SCMs. On the East Coast, it's harder to get slag. There's fly ash available, which is a byproduct of coal-fired power plants. And there are more reactive types of fly ash, and reactive means the ability of the material to participate in the hydration process, right? To cure and harden the concrete.
I want this to be kind of, and I'm going to have to go back and rewatch this about 6 times to follow. So I want this to be easily digestible. And I think what's troubling to me, and then I'm thinking through the audience and just people who will Google stuff there, you see these triggering posts and articles that say, what are the most highest emitting building materials out there? And it'll say aluminum, wood, and whatever, rubber and glass and concrete. And so I don't want to ask how accurate are those measures, but again, how much goes, how do you discern the actual carbon emission of the material versus the manufacturing process? And a lot of what you're diving deep into is how Clark Pacific actually produces the precast concrete, but how you produce it is going to look different to another precaster, is going to look different to another cast in place sub. So how do you find that balance between just reading a headline and saying this is the carbon emission impact of concrete versus what actually goes into producing it?
Yeah, it's an accounting exercise, right? And so we know where all of our materials are sourced from, and there's something called an environmental product declaration, an EPD, and EPDs are produced by product manufacturers and material suppliers for what the global warming potential is of their material or their product. There's some fuzziness there, certainly. There's a number of organizations, companies that can provide an EPD and to a different company, right, to declare what their impact is on carbon emissions. But we get that information from our suppliers, and we know how far away they are from our plant, what the impact on trucking is to get that material to our plant, or rail. We actually have a rail spur that goes directly into our plant that we get some of our raw material in through, right? And so we know exactly what the impact of carbon emissions is of the material that we receive and to get it into our plant, right? And you add those all up and you can calculate what the GWP is of the concrete based on the percentage of the material ingredients that go into many different concrete mixes depending on the product that we're using.
So how much projects come to fruition, especially at massing stage, how much do you see this impacting designers' decision as to what material direction they want to go for the project when it comes to facade material selection, but also structural material between wood frame, steel, and concrete?
I could speak to the structure side, and I'll let Doug answer on facades. I'm seeing it on virtually every project that I work on, is that question comes up more and more, and even more so in the last couple of years. People want to know, and they want to be able to communicate to stakeholders and to the public that what they are doing has sustainability in mind, and that it is legitimately sustainable, and that there's a story that can be told to validate their claims. And that's absolutely something that's accelerating in interest and importance in the market.
And Doug, what about on the facade side?
Yeah, facade is going to have a less impact than the total structure, but we are seeing the question virtually on every pursuit or opportunity that comes in the door. I think it carries a lot more weight right now on state, institutional, federal projects. I think in the private sector, it's a door opener for me. If I have this type of information and maybe more of the marketing behind it, it still comes down to cost. I think it's an advantage if we have the right numbers and are going to still be cost competitive with alternate building materials. Until there's more standards that will be coming, especially here on the West Coast, or requirements. It may not be a deciding factor, especially in the private sector.
So I've been thinking about this concept. If you think about New York City as an island and the infrastructure of it, it's as if you have the foundation, the bedrock has always remained in place. And then, the pedestrians and the cityscape and buildings kind of go in and out and fluctuate over century, but the foundation remains the same. So if you think about a building and the structure core in that sense, if a building owner invests and builds a building, he wants to know that it's going to have the longest lifespan as possible. So if you're thinking about 100-year lifespan, if a building is 80 years old, that's not necessarily the best investment if it's going to have to be knocked down and rebuilt in 20 years. So when we think about the actual lifespan of precast structures and facades versus other materials, what does that sort of maintenance require on the precast front in lieu of, or as opposed to other materials?
Yeah, that's a good question. From the facade side, our durability is one of the biggest value props that we have for owners and clients, and our low maintenance. For us, it's replacing your wet sealants every 20 years, but the precast is going to be there for as long as the building's there. I think one conversation I've been having a lot, when you're talking about just your whole carbon, right? You're embodied in addition to your operational carbon, right? We can talk about performance, right? But as our energy grids get greener and greener, that bigger part of that discussion is going to be about the embodied carbon and the importance to keep it down. The one thing embodied carbon doesn't do is it doesn't look at your whole life cycle. It's one phase, right? So it doesn't, kind of throws out, if, let's just say I'll bring up like an EFIS, right? If we're comparing ourselves to like an EFIS system, well, yeah, you may have to replace or do some major repairs after 5 to 10 years. It's not considering all of that, right? Or it's just of this one product versus precast, which if you look at the whole lifespan, you're going to get a lot more value out of it. And so I think it's really important for people to, embodied carbon is a lot of times the buzzword, but it's the whole life cycle analysis of a building that people really need to be focused on and what the overall impact to the community is going to be.
Yeah, Blake, what about from a structural standpoint? I mean, when you think about just doing sort of, I don't want to say accelerated testing, but thinking long term in the future, 50 years, 100 years past a new build, are you likely not necessarily going to experience structural failures in terms of the anchorage connections and the systems itself? It's just going to have to be sort of intermingle maintenance efforts in terms of, as Doug said, sealant replacement or other little touch-up items?
No, that's a great question. I think that's something that's often overlooked, is that resilience and durability and robustness in design is sustainability. If you do not have a building that's designed to withstand environmental impacts, natural hazards, and that is going to potentially be rendered useless after some sort of either seismic event on the West Coast or a wind hurricane event in the South, right? Or even flooding, these are fire is even more and more of a concern now. Then it's not a sustainable building. You can take into consideration a lot of the front end things and forget the back end and recognize and fail to recognize that it's bad for the environment. And so certainly one thing that I'm very focused on is resiliency of the building structural system. I actually happen to be on the U.S. Resiliency Council Board of Directors, and that's something that we're trying to get out and put the message out, specifically here in California, where I'm located, about, hey, the big one, what to use an overused term, but a large earthquake that is going to happen in the next couple of decades in our lifetime could render an entire city worth of buildings not useful. Not even that they collapsed or that they, crushed people inside during the earthquake, but because they were damaged to the point that they just weren't able to be reoccupied. And then what do? Well, then you just have to throw it in a landfill, right? So that's certainly not sustainable. Taking that into account and designing for resilience, meaning a design that can withstand that type of natural hazard and be continuously operated or reoccupied shortly after the event is critical to take into consideration.
And do you see more of these discussions being had with sort of public clients or institutions versus your private developers?
Yes and no. There are some private developers that actually are very interested in this, especially ones that are doing like biotech lab development, mission critical development, where they're actually marketing the resilience of their structures to end users and tenants, that, hey, they recognize the value of the operation that's going on inside these buildings and of the equipment and machinery or whatever, servers in the case of say a data center. And if that goes down, the significant impact financially and economically to the area that would have. And so it's definitely something that is understood by some, but not all. One of the big misconceptions in the public is that the building code will make sure that these buildings are earthquake proof or hurricane proof, right? That's not true. It's actually a falsehood. All structural engineers, I'm sure there's a ton of you out there listening to this right now, know that a building is designed for life safety. If it doesn't collapse and kill people, then we won. We did our job. But now it can't be used and it has to be knocked down. And we're still patting each other on the back and saying, great job. And then the public goes, what the heck, you guys failed. now all these people are out of work because they can't go to their job, or all these people that are displaced and we don't have anywhere for them to stay. Yeah, but they're alive. We did our job. And so, this is something that happened in New Zealand during the Christchurch earthquake. The central business district was completely decimated, not because people were killed, but because the buildings couldn't be reoccupied.
I'm definitely hearing more about flood mitigation, especially in the coastal areas like Manhattan and South Florida. So that, and then the hurricane impacts, especially with some of the structural integrity of some of the buildings in South Florida as well, is something I'm seeing come up a lot. I think it's, especially because you guys are in California, having to deal with the seismic requirements, as well as the fact that California has been very aggressive with their energy codes. It's been at the forefront and forced Clark Pacific to be an innovator in the precast industry when it comes to sustainability. But do you see these trends following suit with other precasters throughout the country? Do you think governing bodies like PCI are becoming more stringent and codes are following suit, or not necessarily?
Yeah, Doug,
this one's for Doug, based on his little smirk.
No, yeah, I think we see a lot of times trends will start either on both the coasts and kind of move in a direction. We are seeing a lot more energy in our industry and within the PCI about making sure we're ready for new standards, new codes, new requirements that come out. I think a lot of precasters, including ourselves, are still on our carbon journey, right? We started with what is it? We had to do a lot of learning, really, just to get to a kind of a knowledge base of where and how do we make improvements? Where do we stand against alternate materials? And right now, there's a lot of information that's out on that you can go and do research on, that you got to be kind of cognizant and aware of who's writing different articles, what's the perspective, what are the metrics, right? I hear a lot of people always talk about how they'll throw a big thing on and show out the impact of concrete. Yeah, concrete's the #1 cheapest building material used worldwide. There's just a lot more of it, right? So by volume, certainly, but so there's a lot of little things like that. That took us a while, right? Just hiring third parties to analyze our products versus other known products, and I think we're at a point now where throughout Clark Pacific, we're talking with a low level of knowledge around sustainability and embodied carbon that was night and day from just 3 years ago. And I think there's a lot of other precasters that are somewhere within that portion of it still. But I think it's great that we're having more and more conversations industry-wide, partners-wide, right? Different precasters from different regions are talking to one another on different strategies and hey, what did you do to improve it? What did, all this type of stuff. And I think you're going to start seeing that. Well, you have seen it in other industries, and you're going to continue seeing it. Especially as different codes, depending on the state, whether it's your 2040 goal, the 2050 mandate here in California, the new energy codes up in Seattle. States are getting aware of this and are going to be putting in standards and requirements moving forward, and everybody better be ready for it.
So one thing that I overlooked for a very long time, and I think a lot of people don't put enough attention into, is trucking and transportation, especially when you're dealing with such large scale panels and you have to send hundreds of flatbeds back and forth to a job site. How much does that actually contribute, obviously, to cost?
Yeah, this is another misconception. So let me just stop you there, right? If we're prefabbing parts and using a truck to go to the job site, how is all the other material of a cast in place or a steel building getting to the job site? Trucks, right? So how do you reduce trucks? It's about how much material each truck carries to the job site. Precast has a unique ability to do giant loads, right? So you're actually sending far less, if you do the analysis, far less loads from a ready mixer to a location. Then it comes down to, okay, well, the ready mixer to the job site might be a little bit closer. But when you look at the quantity of trucks and the quantity of loads going, it's a very small portion of it. Just because our transportation is a big part of precast cost, people also think, oh, it must be a big part of the operation. No, there's just as much transportation in a lot of other building methods, and we're actually efficient because we can put 60, 70,000 pounds on a load.
Yeah, I think what a lot of people don't realize about the precast industry is that the success of a precast company is so contingent on the surrounding geography or market, within a certain proximity to their plant. Whereas you look at something like the glazing industry or metal panel industry, you might be sending or shipping materials all over the world. So do you watch precast trends in other markets or other parts of the globe? Do you think domestically here we're very innovative and progressive when it comes to precast, or do you think we have a long way to go?
I think Doug mentioned this.
Yeah, why don't you go first, Blake?
Well, I can say this: we're friendly with other precasters in other regions across the U.S. And because we are regional and we're not competing with East Coast precasters, right? We're very open, and we share trade secrets. We share, best practices. I was out at a friend of ours, their precast plant this summer, and going through sharing how we do things, how they do things, to walk their line, and they discussed their design process. They shared their details, and we learned a lot. And we were able to share a lot of the things that we're doing in sustainability with them, that they're starting to do. I'm not going to say they're not doing anything. They are, but what you mentioned earlier is just true. We're in California. We've as much as we care independently without being forced to care about it, which we do. We do have to, because regulatory requirements, but also just the environment of the developers in this area, and the designers too. We've had to grapple with that earlier, and so we do have an advantage because of that. I was talking with a developer just this past week who was working with a precaster on the East Coast, and they asked, "Hey, do you mind coming in and actually helping and working with them on a project that we're doing back east?" We're like, "Well, we don't do work out there." He said, "Yeah, well, just kind of to share some of the things that you're doing with sustainability and in the production of your concrete with them, so that we can hit some of the milestones and the metrics that you're achieving here, and do that there." And I said, "Yeah, absolutely. We'd be happy to have that conversation and share with them."
And I asked that question because I think when it comes to the glazing side of the industry, many parts of Europe have been way more progressive than we've been here stateside, and now we're starting to adopt some of those practices. So looking past here domestically in the States, Doug, what are some things that you've seen when you've gone overseas, whether it's in Germany or Ireland or anywhere like that?
Oh yeah, I mean, I'll speak in trends, right? It's not going to be perfect, right? But what I've seen is typically over in Europe, they're going to be much further along in their EPDs, their requirements, and some of the building codes that they're forced, or that they're obligated to utilize. And so I would say, I have friends over, I'll call them out because they're progressive and amazing, is Techcrete over in Ireland. They've shared some of the things that they've had to do just to continue operating as normal over there. And I would say, yeah, they're definitely 4 or 5 years more advanced than us regarding just the documentation of everything and regulatory initiatives. There's also parts of Europe that aren't, right? So it's not a one rule fits all countries, but I've definitely seen some more advancements over there on that side. Precast is done a little bit differently over there as well. It's more of a commodity based versus a custom product solution, where a lot of fabricators create the exact same products and you kind of buy out of a catalog. It allows them to maybe get further along because they have set parameters regarding a product or a design type, right? Us, it's like, well, you can spend so much time designing a 30-foot by 10-foot facade panel, and the next job, the window configuration and the ratios are going to be completely different. So everything you learned on this job isn't going to be applicable to that job. They don't always have the same or as many challenges regarding that as we do here.
So if it's been commoditized, has it been more popularized, or have you seen it implemented more so in the market?
Precast is used everywhere in Europe. Parts of Europe, right? Germany, Poland, Italy, Spain, Ireland. There's a lot over there. And then in addition, just to kind of caveat off Blake, I think the precast industry for the most part is in it together, right? There is a large startup cost to get into precast, but I think ultimately we all want to push each other forward. I'll say this, regardless if people are in my region or not, right? I'd rather have a job go to precast to my competitor than go to another system solution, right? My job is to build.
You mean like one of my window walls or curtain walls?
Yeah, 100%. Right? You're enemy number one. No, I'm just teasing. But ultimately, it's right. What are you trying to do, Adrian, with your department? You're trying to stock your lake with more fish. So when you are out there with a fishing pole and a worm, you have a better opportunity of catching something. Right? It's the same way, right? And so if my two top competitors succeed, I'm likely going to succeed, and that's got to be your mentality in business. I think in just day-to-day life, right? I think the success of others is only going to help us succeed.
Yeah, I mean, I asked that question about overseas because especially on my side of the industry, the glazing codes and trends are so dictated by the climate zone. So if we go up to one of the higher climate zones, Canada and Boston and Seattle, where it's a heating dominated climate, if you watch those trends in terms of glass selection, window to wall ratio, and what they're doing, you just see it every 3 years as the energy code becomes more stringent. You see that implemented in the next climate zone down. So you can sort of foreshadow what's coming every 3 to 5 years as you have your energy code recycling. And so with some of those trends in Europe, I would just only assume that as we become more sustainability conscious and energy code driven, you'd see some of those overseas trends be implemented here in the States.
Yeah, and just so there's no misconception, when I'm sophisticated, when I talk about Europe, was more of their documentation and the regulations they have to go through regarding embodied carbon, regarding innovation, uniqueness, and stuff like that. I think there's a lot of things that are going on here in the States that are pretty phenomenal and just different.
Yeah. So what excites? I know where Blake's head is at. I want Doug to start here. I know some of the past challenges. What are the current challenges in terms of innovating in the precast industry and being more forward thinking? What are you trying to? What message are you trying to primarily spread out there in the precast industry and in the facade industry?
In alignment with embodied carbon.
Utilization of precast as a sustainable material, can be cost effective, can meet that design intent while working within certain parameters.
Yeah, okay, that makes sense. Number one, I'm excited about the opportunity. When I started in product development about 4 years ago, it was kind of right on the onset of us understanding our embodied carbon, and it's two sides, right? Operational performance and embodied carbon. And a lot of our strategies parallel what Blake is doing over in the structures side of things, but we have a few different key differences, right? We're self-supporting, right? It's a facade, so you have a different opportunity there. In addition, you have a lot of aesthetic requirements that need to be met. What I mean by that is some of the strategies like fly ash, for example, there's just no way you can utilize that in an architectural mix because it's going to have drastic effects on the color and variation from panel to panel. So I get excited about just the extra challenges that we have regarding finishes over here in the facade department. But when I talk about sustainability with my clients and our facades, a couple things that we've done here at Clark Pacific is number one is we have a selection of different products, and so our strategies is don't use efficient concrete. Use the concrete that you need to maintain the design and the aesthetic of the designer, but don't use concrete volume because it's cheaper, right? So we'll utilize different things like back tubs. We call them back tubs, but forms where you're really just putting the meat or the concrete where you need it to support the panels. We've been doing a lot of studies just to say, okay, I know where I'm at, but there isn't one like standard code that says, okay, how does this precast wall compare to this window wall compared to this metal panel assembly? And so I've spent a lot of time using different Walter P. Moore would be one, GlueMac, other third parties to help come in and do life cycle analysis on our facade products compared to known curtain wall, window wall, metal panel systems with similar energy performance. I did this as a baseline, thinking, all this marketing I've heard on the internet is how bad concrete is, right? And I said, okay, well, how bad is it compared to these other products? And found out it's, I'll stand by our products as are, and then we obviously want to improve them. But we historically, if you look at our numbers compared to glass and aluminum, we're going to be close to half in our thin shell and GFRC products, half the embodied carbon. And in addition, you get the durability and the lifespan of precast. So I think it's like a win-win situation. You compare it to a metal panel system, and you try and make enough insulation for your thermal performances to be similar, right? You're typically much higher in precast. We had to do some adjustments there. You're still 12-15% less, and a lot of those decisions went into our product development on, which was, hey, what insulation types are we using? How do we get more effective with our metal frames or our rebar designs? Now, in addition to the concrete, so it's kind of a holistic approach. And then the extra benefits of the thermal mass of concrete and the insulation and what that does to the energy performance of the building. Now, I like to say you're cooking with fish grease, because it really is night and day when you use facade products versus other highly produced facade options out there. I think precast is number one, and I think we have a lot of room of improvement. I'll just simple as that, Adrian.
Is so tying it to Blake, I think about a lot behind the scenes. If you really want to design an efficient building, your facade contractor or consultant has to be interacting with the mechanical consultant to make sure that you're sizing your mechanical equipment properly. But it wasn't until I really got into the precast industry that I realized how important it is for the facade contractor to be collaborating with the structural engineer so that they're sizing the structure properly and making both systems as efficient as possible. Do you think you get the biggest bang for your buck when you combine a precast facade with a precast structure, or that's not necessarily the case?
Hey, I'm going to tell you, yes, absolutely. I know that Doug's going to tell you he's going to put his facade panels on any type of building that he can, right? So he doesn't care if it's precast, cast in place concrete, or steel, right? And I know he's even coming up with, and they've developed details for mass timber, right? Which, I feel a little bit offended, but go for it. You do your thing. You got to sell your panels, but yeah. I think that there's certainly efficiencies if you're able to put your precast panels on a precast structure, no doubt. Not only that, but if we're able to take a precast structural component like a moment frame beam and column and turn that also into an architecturally finished element that you can combine both structure and architecture to create a aesthetically pleasing exterior skin that's also the lateral system for your building, which we have done successfully on a number of projects. It's efficient, it's fast to build, and it's cost effective.
That's what I was going to ask. Why don't you do that more? Just apply some type of finish on the ends of the structure and call it a facade.
We do it. We are doing it, and we will continue to do it. Right now, we'd like to do that on office buildings. We've done it on student housing, on multiple projects. We're focused on doing a lot of other, so on the structure side, mission critical applications and advanced manufacturing, where we're doing that, right? It's less important, the aesthetics, because we're talking about stuff that isn't very pretty to begin with, like a data center, right? But yes, absolutely, we're doing it. It's a huge strategy for winning in sales.
Blake's a little modest. He designed our net zero office platform. If you want to learn more, go to our website. But he did a lot of studies regarding embodied carbon when you have one of those buildings in addition to one of our facades. Where does it fall in the spectrum compared to a very efficient steel building? Right, we have a case model on that, and we're 40% lower, right? When you put all these facts into it. So I highly recommend go check it out. You can always reach out to Clark Pacific to learn more, but we do think if you use precast structures and precast facades, there's a lot of benefit you can get.
So and it's awesome. I think everybody should definitely check it out. And Blake's team is really sort of on the forefront of innovation. And something I struggle with a lot, or a challenge in my head that I grapple with, is you read about sort of these crazy, outlandish, innovative designs, and there's a time and place for it. But when we get back to the basics of just how your everyday buildings are being built, I'll have designers ask questions like, is concrete a sustainable building material? But then I'll see panelized EIFS projects going up left and right. So I feel like there's this big disconnect, and it's almost as if the wrong questions are being asked. So do you think it's just a matter of getting to the right stakeholder? Where do you think some of that disconnect stems from? Misconceptions over the years in the industry, bad information being put out there?
I think it's a combination of a lot of that. I do know there's some new bills coming out in California that can help, some of that information being a little bit more regulatory. But I do think it's also just a thirst for knowledge and understanding. I think we've been on this journey for a while, for a short while. And I think it's going to continuously improve. And then at the end of the day, what's the old saying? The cream rises to the top. When the information is out there, at some point, everybody's going to have to align to the information if it's correct. And so you're going to see a lot more of this come out over the next 10 to 15 years.
Yeah, I think there's this, on a kind of a final note, a lot of people talk about passive house building and passive house standards. And the truth is, building to a passive house standard, it's really not reinventing the wheel. It's utilizing a lot of detailing that's been implemented building over building over building. The only difference is there's actually a means of accountability where they're doing their air tightness testing and building envelope commissioning and making sure what was designed is being built on site. So when people talk about how are we going to get to net zero and, you know, we have to do all mass timber, or we have to do all vinyl windows, we have tried and true practices and principles in the construction industry, and it's just about effectively implementing those details. So do you guys have any response on that, Rand?
I don't. That's just like I don't like any of that. But, no, I mean, ultimately it comes down to, at the end of the day, it still comes down to cost, right? So, you know, if owners, developers, you know, if it was me buying a building, there's the what do I minimally have to produce to actually get this built? What would I like to produce? And there's likely, you know, some medium ground, right? I think that's the world Blake and I currently live in. And each market's going to value it completely different, right? Like life sciences is going to be completely different than developmental multifamily housing, right? Completely opposite ends of the spectrum, right? And that's obviously one reason you don't see EFIS on biomedical buildings, right? Because they value things differently. If you want to put lipstick on a pig, you can.
I think that's an important sort of parting thought for people to think about the durability and lifespan of a building, because you talk to an institutional client who wants a 50, 100-year building, but you also have to think about what is that asset worth after those 50 years, because that's going to matter to them.
Yeah, and when are they selling it, and how are they operating it, right? I think all those go into play. We, you know, typically your more sustainable buildings and higher quality products are going to be geared towards those people that are owning, maintaining, and operating their buildings, right? So they're going to have to be there in 20 years. That might be completely different if I'm building something and trying to flip it in 2 years, right? It just needs to look good when I want to sell it. I mean, that might be a little craft, but that's the reality of things, right? At the end of the day, somebody's paying for these buildings, right? So everybody else can sit on the sidelines and say, we should do this, we need to do that. Yeah, but are they paying the bill? No. And so that's where this is coming to a head, right? And you see these new regulations coming out that are going to require us to do that.
Yeah.
Blake was smirking. I don't know. That was more of a rant.
No, it's fine. I would say I think it's a marketing deficit, really, when it comes down to being able to sell the value of precast and prefabrication. And we're doing what we can. You know, Clark Pacific, we have branded our proprietary concrete mix. We call it Carbon Shield. It sounds like a superhero, you know, Marvel character. But it's, you know, our baseline Carbon Shield mix that we provide in all of our products has a 25% SCM content. So we're removing 25% of the Portland cement, and you get that for free. That's just what we're providing, right? And we have mixes that go up to 70%. So we're doing a 70% slag mix, which, I mean, that's a huge reduction in embodied carbon, right? And when you're talking about putting that into your floor system and a structure, that's 50% of the material in your building. So you're getting a huge reduction. And, you know, we don't have time to get into the details of how we're achieving that. It's relatively simple, and I'd be happy to talk in more detail about how we're doing that. But we have the ability to do things in a manufacturing environment, you know, a controlled environment that you can't do with cast in place and, you know, in the field.
Yeah, I just want to hit on that. You know, at Clark Pacific's core, we want to make the right decisions for the built environment, right? It's super important. It's part of our core standards. And so our continued innovation is how can we provide the same benefit at no cost, right? That's when it's like, then it doesn't require standards. It doesn't require regulations. And if we can do that, we owe it to, you know, our community to do so. And you know, Blake and his team have got to a point where, yeah, we're replacing 25% of the concrete in all of our products just because we can, right? And we want to, right? Obviously, with increased costs, we're going to have, you know, that's where there's a cost benefit. And yeah, having that, being able to go up to 70%. And our efforts now are how can we continue to do that and continue to bring that down, that cost for our clients, right? And so I think that's one thing I just wanted to kind of point out. It requires, you know, a lot of other companies who I think do it just to prioritize it as much as us. And I think we're seeing a lot of those trends in the markets. You know, a lot of our competitors and people are trying to do similar things.
So if we have some superhero designer in Boston, Massachusetts that wants to use this Carbon Shield, is this information that's going to be proprietary or available to the rest of the industry?
Well, I think some of the challenges with the the carbon show is also going to be sourcing, right? So a lot of, we source a lot of our materials locally, and I think, so it's not a one size fits all when it comes to mix design. The things that, a gate precast is using over in Texas and in Florida, their mixes are going to be completely different just because of the different aggregates that they have in their backyards, right? So that's one of the challenges, right? I don't know, Blake, do you want to add on to that?
Yeah, you asked what we're excited about. I'm excited about what innovations are going to be coming in the next 5 years for SCMs, excuse me, and alternative cementitious materials, because just to name drop a couple that we've had extensive conversations with, Blue Planet and Brimstone. They're kind of two startups that are developing zero cement concrete mixes. They're going to have, they have quite a bit of research and development that they still need to do, and extra time and resources needed to get to scale, right? It's one thing to get a teaspoon size, specimen of zero cement concrete mix, right? But then to get it to the point where you're producing hundreds of cubic yards per day. So I still think it's, several years away, but we're going to get to the point where we're selling precast concrete products that have zero cement. It's going to happen, and I'm excited about that. And we're at the forefront talking with these folks and offering our services and our knowledge to be able to help them to get to scale. One, because we think it's good. It's great for the world. It's great for the built environment, but also it's good for business, right? And we want to be able to support that as much as we can.
All right, Blake and Doug, where's the best place to learn about Net Zero Office and Infinite Facade?
ClarkPacific.com.
Thanks for joining, guys. Good conversation.
Yep. Thanks, Adrian.
Thanks, Adrian.
Cheers.